Assalamu alaikum viewers, welcome to my channel Genome Wide Study. If you are new on my channel, please subscribe and press the bell icon so you will get the notification of all the new videos. In the previous video, that was the qRT-pcr part 1, we have done that how to do the qPCR step by step from A to Z. So when you do the qPCR and keep your sample in the thermocycle, so it gives you the raw data in terms of CT values. So in this video, that is part 2, we will do that how to calculate the expression of your gene from qRT-PCR raw data that was in CT values or CQ values through different methods, like one is the constant method, other is the power method. We use these two methods to know that how much your gene show the expression in response to a specific stress or condition, and we also calculate the fold change through delta delta CT method. First, you need that what is the difference between other methods and delta delta CT method. Other methods used to calculate the expression of gene, that a gene is how much expressed or shows its expression in response to a specific condition or stress. While through delta delta CT method, we check the expression of genes in terms of fold change. That a gene, how much change or how much fold change is expression in response to specific stress. So the delta delta CT method can be defined as the method used in order to calculate the relative fold gene expression of sample when performing real-time polymerase chain reaction. So how to analyze these methods? Let's start. When you completed your PCR, so it gives you the values are in this way, that have the values that is A01, A02, A03, and then after A12, B01, B2, B3, like this, and this 4, and also this is CQ or CT value, and this is the mean and CQ standard deviation. I can make it a little bit brighter so you can check easily. And other is the information, that what is the name of that file, and here when it was started and when it was finished, how much the sample volume and the fluid temperature, blah blah blah. So we need in this column, we need only this column and these two columns we need, so we can other you can maybe hide or so we need copy maybe you can paste and then copy these two columns and paste it here. You can delete this one. So this is the well CQ, and we have written in the last video. I asked you that you can note that in your notebook that what was these samples are. So in the previous video, so we used this A1 to A9, that was our gene. So here gene 1. These are our gene 1 sample. These one our gene 1 sample from A gene 1 to A1 to A9, and here A10 to A12 was gene 2, B6 was gene 2, and B7 to C3 our gene 3, gene 2, gene 3, and C4 to C12 were our gene 4 samples, and B1 to B9 was our internal control or acting. If you are new on this video, so you need to watch the previous video. The link of that video is present in the description, so you can understand that how we label these genes, these values, gene 1, gene 2, gene 3, and gene 4 and 18. This was we have already done in the previous video. And also remember that A1 to A3 was our control sample, and A4 to A6 was our OER sample 1, sample 2, and also these were the knockdown. So copy this, paste here, because it was the same case with gene 2, gene 3, and gene 4, and also for actin. Now we calculate the expression of each gene through first method, that was the constant method. For this method, first we need to minus the CQ or CT value from 40. This is the constant. So for minus, so write is equal to 40 minus this CT value and drag it up. Yeah. We didn't have our sample in these columns or well, so better to delete them. So it is better to manage it after decimal 2 figure. So it will come like this. Now we multiply it with power 2 power that value that we have got after subtracting the 40. So here it is equal to 2, and then press the sign that is a power sign, this one, and then this value, and enter, and now drag it down. Also change them format cell, and after decimal point we will only 2 figure. Here we need the actin value that we got from the power after power multiplication, this one, these values. So copy these actin values and paste in front of each gene's value. Now we need to divide the actin value over our gene's value. So it is equal to, this one is our gene value divided by actin value. And now drag it down. So this is the expression of our first gene in control, and this is the expression of our first gene in overexpression samples, and here is the expression of our gene in knockdown. But now we need to make their average or mean. So it's equal to average of these three samples. Now here also is equal to average of these three is equal to average these three samples. Also copy and paste it in front of this one. First second way. So automatically formula takes that value and convert these. So this is the expression of your first gene in control sample, the expression of first gene in overexpressed or other samples, and these are the first gene in another sample. This is the expression of second gene. Now we need to calculate the standard deviation. Take formula from here, you can ask this is the FTD. Okay, and here these are the expression of the replicate. Here you can also standard deviation of the also copy the so this is the expression of your gene in control sample, overexpression and knockdown, and this is the standard deviation or standard error. Standard error you can also calculate like this. So is equal to standard deviation divided by number of replicates, or how many number these standard deviation we got. We got this standard deviation from these three values. So here is divided by 3. So you can also calculate the standard error. So in error bar you can use standard error or standard deviation. Both are fine. So now you can make the graph from this data. How to arrange it? So you can like this. Control overexpress knockdown. Here you can make the gene 1, gene 2, gene 3, gene 4. So copy, paste, and transpose. First, we remove the formula from these values. For removing the formula, you can copy and now paste special value. Now copy, select the copy and select and transpose. There is also Now the second gene expression, copy a special transform, copy, paste the values in front of third gene. Copy and paste the values in front of fourth gene. And now let's go to insert, and these are the graph, bar graph. So this is a expression of one gene. These are the values. These are the expression in control, overexpression, and then knockdown. Here also these are the expression in form, in the graph form. You can make this. You can also make these graph alone. Means for each gene you can also make the graph separately. For that you can only select one gene, and this is the graph for only one gene. And then like this way you can also make the graph for second and third gene. So this is the method for expression calculation of each gene in each sample through constant method. Now we will calculate the expression from these CT values through power method. For calculation of expression from CT values through power method, we need to copy these values, copy, then here you need to paste. Now we need here the CT values. We need to copy the CT values. Here are our CT values of actin. Copy these actin values and paste in front of each gene's CT value. But remember, carefully paste. You must paste the actin CT values of control sample in front of control samples of gene CT value, overexpression in front of overexpression, and knockdown in front of knockdown. Now you need to calculate the expression. Now you need to copy that actin value, CT value of your actin in your sample, and paste them in front of all the gene CT values. Take care when you pasting your CT values of gene or actin that both the gene CT value and actin CT values of the same sample. Means here this is the gene CT value of the control, and here also the actin CT values of control. Here is likewise overexpression and knockdown. Now you need to put the formula to get the expression level, like is equal to power bracket start 2 is the constant, right? 2 comma. Now actin CT value minus gene CT value and enter. So it will give you the expression of your gene. And now drag down, so you will get the expression of your gene. Now you can calculate the average intro of copy and paste it. For cross check that you have copied the right column or a cell. So when you cross it, so it will that show that this is the average value of from these three cells and these are the selected ones. In this way, you can also calculate the standard deviation as we have calculated from the previous one. So this is a method to calculate the expression of your gene through power method. So now you can compare these both methods results that you have the same expression values or have some fluctuation. So you need to copy that values expression values that we have got through the constant method, and now you can click here and then check. You can see that from both methods we got the same expression of our gene. So these are the two methods used to calculate the expression of your genes. You can use any one that you can feel that it is easy to use. Now we can calculate or we use the delta delta CT method to calculate the four expression change. For calculation of whole expression gene through delta delta CT method, we again need to copy the CT values, copy, here you can paste. I have already written the formula to make myself easy. So now you can copy the CT values of 18 and paste it in front of every gene CT value. Now we need to calculate the delta CT. So delta CT is comes to gene CT value minus actin CT value. Gene minus actin CT value. So here drag it down. Now we need to calculate the average of control, only control average. So here is equal to average. These are the control samples. Intro. Here also is equal to. We need to only calculate only average sample. Control sample average of each gene. Here also so this is the average of control samples of each gene. Now we need to calculate the delta delta CT method. Delta delta CT. So it will come from here. You can is equal to that the sample. This one is the sample CT minus average CT that we have got from the control average. Here also is equal to this one, the sample city minus control average is equal to sample 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 minus control average. This was the first gene. Now we have started the second gene, so we take the average of the second gene. And when we start the third gene, so we take the average of the third gene. After calculating delta delta CT by subtracting the average value from the sample CT delta CT value. Now we need to calculate the expression that we get from power to delta delta CT value. So it is equal to 2 power minus that sample delta delta CT value. So drag it down. So here you can see the average for expression. So we can here take the average of these three. Now here average of these three samples and also average of these three samples. Copy, paste, so when you make it after format it, that is after decimal point we need only 2 figures. So here is the expression in terms of fold change. In the delta density method, you calculate the fold average fold change. So in that your control sample must have the value of 1 or little bit fluctuation or 0.01 or like this. It must have the 1, and then the other values change how much fold. So here is our control, and this one is the change in expression in term of fold change to 1.7, means 1.7 fold higher expression this didn't show in the overexpressed sample, where the 0.04 change in knockdown. Here is the sorry, in this gene, that the gene 2 has shown 3.58 fold higher expression in overspread samples, where 5.44 fold expression higher in knockdown as compared to this control one. And then you can make them or express them in terms of bar figures and like like this. So this is our video that how you can calculate the expression of your gene from raw data that was in the form of CT value through two methods, that was the constant and the power method, and also delta delta CT method to calculate the fold expression of your genes in the treated samples or overexpressed or knocked down samples in compared with the control one, and then how you can express them in the form of bar or graph. So this is our video. Hopefully it will help you. If you have any query, please comment or email. Please like, share. Thank you.